Okay, let's say we've got a circle in general form x squared plus 4x plus y squared minus 6y plus 7. We see that this form agrees with the stated general form here. A is equal to 4, b is equal to negative 6, c is equal to 7. We want to put this in standard form and graph, and we know that to do this, we want to complete the squares on the x squared plus ax, that would be our x squared plus 4x, and y squared plus by, that would be our y squared minus 6y. So what's the, well, what do we get? Let's complete the square on the x squared plus 4x. So we complete the square on x squared plus 4x. Okay. So we have x squared plus 4x. The rule for completing the square is we square half of the coefficient of x. Now part of the rule is that we got to have a 1 in front of x squared, but we've got that. So we can safely square 1/2 of the 4. Half of the 4 is 2. And 2 squared equals 4. So what are we going to do? We're going to add 4 and subtract 4. This is still equivalent to x squared plus 4x, because adding 4 and subtracting 4, well, we can subtract this 4 from this 4, and we get right back to what we started with. It's completely equivalent. Now the reason we put it in this form, and I'll come down here, I can group that as x squared plus 4x plus 4 minus 4. And then x squared plus 4x plus 4 is easily seen to be a perfect square if you know how to factor and if you know how to locate perfect squares or recognize perfect squares. This is x plus 2 quantity squared minus 4. Now notice that the standard form, we got to have an x minus h quantity squared. So if we replace x squared plus 4x with x squared plus 4x plus 4 minus 4, which is perfectly valid again because the 4 minus 4 is really just 0. But putting it into the form that we get if we group it like this so that we get a perfect square, well, we've shown that x squared plus 4x is the same as x plus 2 quantity squared minus 4. So we can replace x squared plus 4x by this expression. And we're halfway there in getting our standard form. Now we have to complete the square on the y squared minus 6y. I recommend that you go ahead and do that right now. I'm going to write some stuff on the board so it'll be there when you come back, which will just seem like an instant here. Okay, to complete the square on y squared minus 6y, well, here's our y squared minus 6y. We take half of 6, which is 3, we square it, we get 9, so we have plus 9 minus 9. So we can even say y squared minus 6y equals y squared minus 6y plus 9 minus 9. And we can then group the y squared minus 6y plus 9 and put the minus 9 out here. And y squared minus 6y plus 9 is easily enough seen to be the square of y minus 3. So we get y minus 3 quantity squared minus 9. So what happens to our equation? Our equation is x squared plus 4x plus y squared minus 6y plus 7 equals 0. That's equivalent to x squared plus 4x is the same as x plus 2 squared minus 4. And y squared minus 6y is the same as quantity y minus 3 squared minus 9. So we do that replacement. Here's our completed square on x squared plus 4x. Our completed square on y squared minus 6y. Our 7 is still there. And then we just put our -4, our -9, and our 7 together. That's going to give us -6. If we add it to both sides, we again get x plus 2 squared plus y minus 3 quantity squared equals 6. That's a circle with center at HK. Now, it's x minus h quantity squared, so what would we use for h to make this x plus 2? Well, h would have to be -2. X minus -2 would be x plus 2, so that would be it. So the center has x coordinate 2 and y coordinate 3. Y minus 3 is your y minus k. HK is your center, so we have 2 minus 2, 3. Radius, well, what's the radius? R squared is R is the radius. It's squared on the right-hand side of the equation, so that R squared is 6. And R is the square root of 6. So we've completed the square on the x part, on the y part, and rearranged the equation and discovered the center and the radius of the circle.